can start. So, good morning, everybody. Welcome to this EHI European Heating Industry online event focusing on hybrid heat pumps, no-regret solution for the decarbonization of buildings. We are we're going to have a discussion with three speakers that will, on the one hand, present this new technology, and I'll show you here the new publication that we have done and upon which this is based. And we're going to have a discussion about their benefits, the characteristics, and also some concrete examples of how these technologies are already working in the market. The idea of this event was really to showcase a technology that is growing the market, but that we also believe is going to grow more in more markets. It's an interesting combination. It's a hybrid heat pump. I will not go into the details now because Valentina will. So it's a technology that somehow we believe can combine in a very practical way best of two worlds, has been said as well, and therefore combine different energies and deliver both on energy efficiency, but also on increasing the penetration of the technologies of heat pumps, in particularly for the buildings renovation market. So it's something that we've studied, and our members companies have been developing already for some years, and we thought it would be interesting to have a bit of a look today at how they function, how they work, what are the characteristics, and indeed how the different models of hybrid heat pumps are taking more and more space in different markets. I will just briefly introduce the speakers that we have today. That's Valentina Da Conti, who is a Standardization and Regulatory Affairs Senior Manager at the company Imergas. Imergas is an Italian manufacturer of heating systems. And Valentina herself is an expert on the technologies and active very much also on a lot of technical committees, both in Italy and at international level. So welcome, Valentina. Thanks for your time. Then we have Walid Atmar, who's project manager at the Netherlands Verwarming Industry, if I pronounce it correctly with my Italian accent, sorry. Walid is indeed working for the Dutch heating industry, and he will be talking to us specifically of a very interesting project that you have carried out in the Netherlands, not only installing hybrid heat pumps, but also monitoring the performance in terms of energy efficiency, CO2. So I think that's going to be a very interesting asset in our discussion. And then last but certainly not least, Fabio Parola.
Parola.
Easy. You are EU Public Affairs Officer at A2A. You're based in Brussels, but you represent also an Italian company, different same sector, energy sector, but obviously not a manufacturer of heating system, but rather an energy company that is active in the distribution level, and therefore has to manage somehow the before the meter, let's say, element of the energy transition, particularly on decreased electrification. So we're very much actually connected as industries, and more and more we will be. So it's very good that you could spare your time to be with us on this meeting. Perhaps we'll start with maybe first round of questions, and then if participants want to put some questions, there is a chat where you can put a question to the speaker, and depending a bit on the time, we will try to put the questions to our speakers and have a discussion. That's really the aim of today. We have 1 hour. I would start with asking the first question to Valentina, because you've been also very much active in and participated in the in writing this this paper, or contributing to this paper. Tell us a little bit, what are hybrid heat pumps, what kind of hybrid heat pumps there are on the market, and how they function, what are the benefits? I think you described in a little bit the technology is useful, and maybe we can start making reference to that, and then perhaps we'll go a bit more into how you see the market in Italy, but maybe we just start with a description.
Okay. Thank you so much, Federica. I'm very glad to speak about hybrid heat pump today, because I'm really convinced that they are the key to reach the European targets. As what you said before, the challenges on existing building, and these products are very, very important for existing building, because nowadays everyone speaks about energy transition and decarbonization and so on, but we know that transition is not an on-off process. We need a clever integration of energy, of technologies, and hybrid heater we have developed in these years, because we are not ideological or theoretical based, but we are practical and pragmatic. We have decided to develop these products just to reach the targets, the climate targets the European has set, the Europe has set. So we have developed this paper because we want people to know more about hybrid, because it's a almost new product. Italy has been one of the first countries developing this product, and we have decided to show more about this. We have identified 4 types of hybrids. Maybe I can show some slides. Yeah, maybe it's better. Well, we have described 4 types of hybrid, but the focus of our paper is the factory-made hybrid, because factory-made hybrid is a product. Combining together 2 products, a condensing boiler and an electric heat pump, and 2 energy carrier, electricity and gas. So it's very interesting for the transition, as we said before. The product is not only these 2 heaters, but the brain of the product is a master control, which is able to optimize the working condition of the products in each moment. This means that this master control is an integral part of the product, and is able to optimize the hybrid heat pumps based on different parameters. For example, the CO2 emissions, the reduction of CO2 emission, the reduction of fossil fuel consumption, the minimization of running costs, for example, and also, not very important, last but not least, the optimization of the electricity grid, because when you have a peak on the grid, you can disconnect the electric part of this product, and leaving the consumer with his heat delivered by the gas part of the product. This is technically speaking, and also another important thing is that in these products you have only one manufacturer liable for the whole product, and also there is a proper sizing of the heat pump respect to the heat load of the demand of the building, because sometimes when you have a standalone heat pump, you have to dimension it based on the peak load. So usually it works being oversized. In this case, you have a proper size, so it is sized for the average load of the building, but while in the peak, the heat is delivered mainly by the gas boiler. Okay, this is technically speaking, this is an hybrid, a factory-made hybrid. So the key points are 1 manufacturer, master control. We can have also a factory-made hybrid in 2 parts. You have the hybrid-ready boiler, which is a part of the complete hybrid. which can be delivered separately. Why this is important? This is important because sometimes you have to replace the boiler when it breaks down, when it fails, and you can only replace that boiler. And if you replace the boiler with, let me say, a normal boiler, not hybrid ready, you create a kind of lock-in effect. While if you install an hybrid ready, you are ready to implement, to improve your installation by means of the additional, the complementary heat pump, which will complete the whole product. Also in this case, the liability is by one manufacturer, because the second part is placed on the market by the same manufacturer according to the instruction given by the first manufacturer, the one of the boiler. Okay, then we have other two, a small jump. We have other two situations. The packaged hybrid, which is a package according to labeling directive, in which you can combine on the heating system two different products, one heat pump and one boiler, but you don't know if they dialogue each other, if they are able to make all that control we have described before for factory-made hybrid. And then there is the add-on, heat pump as an add-on, addition of an heat pump on an existing heating system where you have an existing boiler. Maybe this kind of addition can work in some markets where condensing boiler are already widespread, are the vast majority of the existing stock. But what happens in Italy, for example, and why hybrid are the solution for Italy? We have a situation in which we have lots of old buildings with poor insulation, with high temperature emitters. Homes with gas heating system are more or less 85% of homes in Italy. And also we have about 18 million heating systems fed by gas heating system, and also some other millions with gas bottles, cylinders. We also have, okay, we have the colleagues from distribution, but we have maybe 300,000 kilometers of gas grid in Italy. So everyone have gas in their home. So it's very difficult to change the mind of people and to skip to completely other technology. In this case, and we have also, in 2022, about 50% of the stock made by, still now, low efficiency boilers, standard boilers. So if you go towards the add-on, in this case, you add a new heat pump, a very performant heat pump on an existing boiler, which is very old, which probably or surely will not dialogue with the heat pump and will not give all the benefits you have with hybrids. This is why maybe the add-on can work in some countries, but not in Italy. In fact, Italy only gives incentives for factory-made hybrids, and it is the first market for factory-made hybrids. These are the numbers in Italy. We have in 2022, we have had 120,000 pieces of hybrid in the market, which is, this means that it's the first European market. But now I will go back very quickly to the benefits we have. The benefits are various. High compatibility with existing building, well accepted by the end user who are used to have gas boilers. Very high savings on all the parameters, so CO2 reduction, fossil fuel consumption, and also bills reduction, energy bills reduction. This is a scheme you can find on our paper. I invite you to read. EHI paper, because you will find all the numbers, so I will not go through everything. But what is important is that also in Italy we made some studies. What is important is that in existing building with existing situation, we know that buildings are all different age, different insulation, different heating system. You need the compatibility in order to reach the goal. Otherwise, people will not change the old boilers. And hybrid have the highest performance under all the parameters you will find in this slide, for example.
Valentina,
yes.
Can I just stop you for a second, because I want to ask you more about Italy in a minute. But can we maybe move to Walid, because you mentioned the difference. Okay, Italy mainly market for factory-made hybrids. I just wanted to go a bit with the other option, which is that we see in the Netherlands, and then maybe we go back to the specificities of the markets, because I think that's also interesting. You gave already some numbers, but I don't want you to say everything immediately.
Okay.
Walid, tell us a little bit about how the Dutch market is developing on hybrids, and also about this study you did in monitoring. You actually installed a number of them in number of houses and did monitoring exercise on them. And I think that's very interesting. Can you tell us a little bit the why and the how, and also what the results have been? And you need to turn on your mic. Very good.
Thank you very much. By the way, before I forget, I want to commend you, because not only did you get the name of the association right, but you pronounced my name perfectly, and that is the bigger achievement here, actually. So thank you. Thank you.
The week is work.
Yeah, just to follow up on the Valentina also said, she basically gave the arguments on why the hybrid heat pump, from a technical point of view, is a very good solution to decarbonize. And our association is actually also born out of a societal concern. One of the societal concerns is, how do we do that with support from the people that live in the existing building stock? Because we have to renovate those houses with efficient systems and basically involve them as well. So what we did is we looked at what are the options, but also assessed those options against the criteria of, is it technically feasible? Is it economically feasible? But also, does it have the support? And with the discussions that we had within the industry, the hybrid heat pump relatively quickly came out as one of the options to quickly decarbonize the existing building stock. But that was a theory. And what we had to do, what we felt like we had to do, which is also our responsibility as the manufacturing industry, is to prove the theory. So we set out to, together with our industry associates, to demonstrate, which is why, quite fittingly, the project that we have conducted is called Demonstration Project, and not a study and not a testing, because we believe that this is the right solution for a large part of the existing building stock. We have roughly 200 houses which are currently being monitored, which are equipped with hybrid heat pumps. And what we're doing is we're looking at the initial situation where these houses were fitted with gas condensing boilers. And then we installed the hybrid heat pump as a new boiler and as a new hybrid. And we basically compared those two situations without any additional modifications to the houses that they were applied in. And just quickly, I want to give an example of what kind of houses are part of this demonstration project. You can see my screen now, and there's two reasons why I like to show this image. Firstly, because it shows the variety of the types of dwellings that we are monitoring in, to show that it has a wide use case. But secondly, which for me personally is equally as important, is just to address the stereotype that in the Netherlands all houses look the same. So in this case, it's not. So basically, we have a wide variety of houses where we've conducted these tests, and I'm not going to go into the details in the graphs, but just to see what the results are and what we have learned in the past 2 and 3 years. This is just from the first 120 houses that we have monitored. When we look at the construction year, it varies differently from the 30s even to most recent years, and we have various dwelling types, as we've shown. And these are the interesting numbers, mostly. What happened in these dwellings before we install these hybrids? And what is happening in these dwellings after we've installed these hybrids? on average, we can see, because in the Netherlands, we have two policy goals, actually. We have to reduce our natural gas usage, and we have to reduce our carbon footprint, which in some cases, if you follow the discussions in the last couple of years, one does not necessarily help the other out. And this is especially the case with the hybrids. So, but we see, however, that with the hybrids, we have a significant reduction in natural gas usage, which to a certain degree, of course, is compensated by the use of additional electric energy for the heat pump part of it. But still, in the vast majority of these cases, we have a net CO2 emission reduction, which is actually the goal, what needs to be of our policy. And this is the value of the feedback loops like this that we as a manufacturing industry need. We need to be able to demonstrate the technology that we produce also works in practice, because this way the support for these kinds of installations and systems is actually increasing. But there's one important point that I want to add to this as well, and that's luckily with another photo or image. We are very focused on the appliance, the single appliance of the heat pump together with the boiler, and we're looking at that. And I'm sure that the industry can make the most efficient hybrids that are physically possible. However, we have to realize that these appliances also need to be installed in practice. And we don't necessarily know the situation behind those doors. Where are these appliances going to be installed? Well, one of the values of a demonstration project where we actually go inside the houses and see and get that feedback what these appliances do is that we also see how the total system works and how it affects the efficiency of the appliance. There's one fitting example that I want to show, and it's this image. And this actually happens quite a lot in the Netherlands, which is that people renovate their houses all the time. They have standard flooring, and maybe over the course of the years, they don't want to change their floors, but they just add every layer of floor on top of it. And what we have seen in some cases is that this affects the heating distribution and delivery of the room heating. To the degree that it also affects the efficiency of the hybrid heat pump, because it needs to work more to deliver that energy. And with these kinds of discussions, we've seen that it also helped us as an industry, to be honest, to realize that the situation behind the doors is very critical to the performance of the heat pump in general. And that was actually a very valuable lesson for us. Of course, we have a technical background. We know that the balancing of the distribution and delivery affects the appliance, but to a degree that right now we are investing a lot as an industry, but also as a country in the hybrid heat pump, because from 2026 onwards, we have a efficiency standard implementation in the Netherlands, which basically means that if you're going to renovate your heating system, the minimum appliance or system that you are required to install is a hybrid. So from 2026 onwards, that is basically going to be the standard in the Netherlands. But then we have to realize it's not just about launching these appliances into the market as a standard and forcing people to go towards our hybrids. We have to communicate about the advantages that it have, but also about the requirements and how to have these appliances basically operate efficiently. So right now we're having industry discussions with our basically the partners that we have to cooperate with, installers, other advisors on how do we make sure that these installations, these appliances in practice work efficiently as a system instead of an appliance. And those are actually very fun discussions to have.
Yeah, thank you, Walid. And I think the word system is indeed very interesting and very fitting, because not only we are not working alone where we install a technology in a house, but we need to work with the energy system around us, which is a great way to talk with Fabio about the other side. So with an increased electrification of buildings, which is already happening, and we expect it still to grow. Obviously, there's going to be much more of a stress also on the electricity grids. This is now finally, I mean, this is something that we've been talking about as industry already for some time, but it's really has been taking a lot of attention also at European level, with even a new plan from the Commission for grids. I just wanted to ask you, well, first, maybe if you wanted to say a couple more words about your company, but also how do you see and what are the solutions for you to deal with increased electrification? Or maybe you are okay with the, you have already a plan and it's all fine. But if it's not all fine, then what are the challenges and what are the directions that you're looking at to make sure that you have a resilient grid? Because that's, of course, a preconditions for then the appliances to work in the field, in the homes. Without which, we have no workable solution for our customers, and our customers is basically us, all of us in our homes. So Fabio, over to you. Tell us a little bit from your side how you see it.
Yes, thank you very much, Federica, and to EHI for the invitation. Just allow me to spend a couple of minutes to introduce the group A2A. We are one of the main Italian public utility companies. We are a private company which is majority owned by the cities of Milan and Brescia, who are our majority shareholders, while 49% of the company then is traded on the Milan Stock Exchange. So we have this twin public-private nature, which leads us to be very rooted in our home territories, but also active now all over Italy. We are active on the energy side, but also in environmental services. We are the largest waste management operator in Italy and one of the main in water distribution. And when it comes to energy, we are active across along the whole value chain for electricity in generation, distribution, and sales, and on gas for distribution and sales. We are then operating on a range of other services. For example, we are the main operators for district heating networks in Italy. We are active also in electric charging infrastructure for mobility, and a number of value-added services like energy efficiency renovation. So we are also active, let's say, we are part of this process of renovating houses and increasing energy efficiency, lowering consumption, also in view of decarbonizing the building stuff, basically. So we are a rather balanced company in terms of having a wide generation portfolio. So we cover all energy generation technologies. We have a diversified customer base, balanced between gas and electricity. And let's say we look at all potential energy carriers that can lead us to decarbonizing our energy mix and our consumptions. Within the group, Unareti is our DSO, our distribution system operator, both for gas and electricity. Unareti is mostly active in Milan, Brescia, so our two co-owners, let's say, but also in the surrounding region. And they operate approximately 20,000 kilometers of distribution grids. We're very proud of Unareti. It's a very advanced DSO. It's recent news in the last days. Unareti got, for the third year in a row, recognition under the gold standard of the OGMP 2.0, which is the United Nations framework for methane emission reduction along the gas distribution network, basically. We're very proud of this achievement, which testifies to the effort that Unareti puts in staying on top of developments, both on electricity and gas. We have, as a group, a long-term industrial plan that looks now at 2030, but is actually being updated these very days and weeks to 2035. We currently, to 2030, foresee an investment of 16 billion euros on both energy and circular economy. 11 billion will be on the energy transition. And it will be it's interesting to notice that basically 30% of these 11 billions will go to the renewable assets, new production of renewable electricity, but the same amount roughly will go to the grids to strengthen our electricity grid, which links back to what Federica, you were mentioning regarding the importance of now investing in electricity grids, but also in doing it in a smart way. That means considering the best available, let's say, energy vector, energy carrier for each specific situation. Indeed, we see a role for a range of technologies in decarbonizing our building stock. I was mentioning district heating, for example, electricity, of course, but also gas will play and will still play in our forecasts a very important role to 2030, 40, and onwards. Of course, gas, which will be increasingly decarbonized. We are stepping up also biomethane production, and we aim to produce 170 million cubic meters to 2030 from municipal bio-waste and agricultural waste. So just to give you an overview of the company and its plans and how it sees the way forward in decarbonizing energy consumption and the building stock. Moving then to the specific challenges of electrification and how sector integration and technologies like hybrid heat pumps can help us. I would maybe just focus on the situation that we see now in Milan, which is of course which is an area with a high population density, huge energy demand, and unfortunately a relatively low potential for renewable energy production. There's a lot of spatial constraints, also in terms of deploying, for example, storage technologies. And so we have to operate with a very careful and very smart approach to make sure that we are deploying the right technology in the right place, let's say. Milan today already is facing lots of challenges for its electricity grid, especially in summertime, where we have, let's say, a twin challenge of increased energy demand, of course, from air conditioning, but also the electricity grid, which is under a lot of stress due to the temperature rising in the city. This is forcing us also to consider the needs for increasing the resilience of our electricity networks. This compounds then on the challenges related to the limited availability of space in dense urban areas. So as Walid and Valentina were showing, heat pumps usually require a certain amount of space to be installed. And this means that in cities where the most usual, let's say, unit is a multi-apartment building, for example, with 20 plus families living under the same roof, there's not always the possibility to, let's say, to go full electric and to provide each household with its own heat pump. Another challenge, of course, relates to the cost of electrification. So the cost of building new infrastructure. We are operating now under, let's say, time constraints. 2030 is just behind the corner, so we need to move very fast, and we need to use our resources in the most efficient way. In Italy, as Valentina was mentioning, methanization in many areas was relatively recent. So we have an infrastructure for gas distribution, which is quite new, quite efficient, with a very low rate of methane leakage. And it would not make a lot of sense to, let's say, to replace this infrastructure with an electric distribution grid, which would cost us a lot of time and resources, while we could instead opt for a more, let's say, balanced approach and a more sector integrated approach. Just to give you some figures, very, very concrete on the situation in Milan and how we see it evolving. We see a lot of potential for full electrification, for example, in the non-residential sector, where you have perhaps less spatial constraints, so you have more possibility to go, let's say, full electric in that respect. And here we see actually, after 2040, a vast majority, let's say, of final consumers being fully electrified. But this is not true for for residential customers. Here we will still need a lot of gas, a lot of course renewable gases, but we will not be able to go full electric here. And this is why it's important to let's say, incentivize and recognize the role of such technologies as hybrid heat pumps and the role that they can play. In this sense, we are very happy to see what was decided now at the European level with the recent revision of the Energy Performance of Buildings Directive, which recognized both the role of renewable electricity and decarbonized renewable fuels as energy carriers for the future zero emission buildings. And this is indeed a point that we stressed a lot in our work here in Brussels in the past months. So the need to, in each specific situation, be it a city with a high population density, a rural community, a region which is subject to heat waves, or a region from Northern Europe where heating is more important. In each situation, to recognize the most suitable technology for the heating and cooling of the building sector. So we were very happy that the possibility to create synergies and to have a sector integration for the building stock was recognized in the EPBD. And yeah, we think this is indeed the way forward. Let's say not to choose top down one or one technology or the other, but to allow all potential energy carriers to play their own role in the decarbonization process.
Yeah, thank you, Fabio. Can you go back to Valentina now that we are on Italy? Because you, and also Walid mentioned the consumer, actually, especially Walid mentioned the consumer aspect, or the consumer, let's say, attractivity of the product was a consumer aspect. And I think that's quite an important one. As we've seen, actually, the debate on the heating transition in a few EU countries, including Germany lately, been very heated on technology. So I think it's important indeed to look at how much, how we can make sure that the technologies are actually accepted by the consumer that have to live with them. Being Italy the #1 market at the moment on hybrids, is this aspect, or is there an aspect then of hybrids that is particularly attractive for consumers that explains then the fact that it's the first market? Or is it because of, I don't know, the interaction with the grid, the fact that, within a system it works? What would you say is the main reason, or one of the main reasons that are explaining the success for the time being of this technology in Italy specifically?
Well, there are two main reasons. The first one is incentives, of course, because Italy has set an important incentives program since 2016 for hybrids. And so they are fully recognized, and when who can decide to plan to replace the boiler can also take the advantage of incentives. So incentives are an important trigger. And we have also experienced in this last year a drop of the market just because there's been a great uncertainty on the incentives. So incentives are still now an important trigger for hybrid market development. This is one point. The other point is that in new buildings, as we are not yet obliged to go fully electric, but it is possible it's required to have at least 60% of renewable in new buildings. The vast majority of engineers, of designers, choose hybrid because they are more used to gas boiler in the past. And so they want let me say, the confidence that everything goes right everywhere. And so they want to have the backup boiler. If one breaks down, the other one works. They want to take advantage of the existing grid. And so all what has been said before is taken into account when the engineer has to design his heating system. But first of all, in existing, the trigger is the incentive.
And I think this is common for all new technologies, which is also that is indeed driving or not driving the market in general for heat pumps. So that's certainly something that needs to be considered. Walid, is this monitoring exercise being extended, or how is this? What's the plan?
The plan is that for this winter season, there are still 80 dwellings being monitored. The 120 that are finished, we have gained some knowledge on them. And in these additional 80 that are right now being monitored, there are some additional interventions being done, because so far we have enough information that basically demonstrated the importance of the hybrid. We're now just experimenting a little bit more with more energy saving measures, such as hot water recovery devices for showers and stuff like that. What's the effect of that? But if I might, Fabio pointed a very interesting discussion on the investments in the energy grids, and I commend, by the way, for all the awards you've gotten for that. So great job. So congratulations on that. But there's actually a very important advantage of hybrids in that context, because when it comes to the energy grid, yes, we agree that we have to invest in the capacity of the energy grid. But additionally, we also truly believe that we have to invest into the intelligence of the energy grid. Because when we look at the decarbonization of the built environment, you can do that by reducing the fossil energy usage, but also by increasing the renewable part of it. And that renewable part, unless Elon Musk has some brilliant idea, we are still dependent on solar and wind, and those are aspects that we cannot influence. And actually, when we look at the very strict goals that we have for the future, we believe that we have to make the transition from demand-based energy usage to supply-based energy usage. When do we have sun? When do we have wind energy? And at that moment, when that is available, then we need to have these smart appliances that can be flexible. And we believe that the hybrid heat pump has a very important advantage in that aspect, that we can also offload the energy grid at the moments where the capacity is a little bit high, so to say. And that intelligence, we believe, is also an aspect that consumers value, because, and that's fittingly why I like the EHI paper. It's called the no regret solution. From the Dutch point of view, what people fear, well, fear is maybe not the right word, but what are holding them back from investing in certain solutions is, if I go buy a boiler now, if I go buy a heat pump now, what will happen in the policy landscape 5 to 10 years from now? Are they gonna come inside our houses and remove them from the walls, and we have to go with something else? The no regret solution, that is such an important aspect in the communication towards the end users, to give them that feeling that they're investing in a future-proof technology that is also helping the sustainability goals. So that is definitely something I would like to add.
Yeah. And in that, I have to say that I would imagine the installer, again, is a key part of that communication, because that's the interface between the technology and the user. So installer, but also, like Valentina was mentioned, the architect, the engineer, let's say, that designs the house or that designs the renovation of the house. So I think that's an important element. I have a couple of questions, looking also at the time, that perhaps I will pick up. So again, if there's anybody that wants to put questions here, you're very welcome to. So first question that I see is about more the technical specificity, let's say, of heat pumps. And the question is, what should be the main parameter for the master control of the hybrid heat pump to achieve most CO2 savings, and how to ensure that this is put in practice? It's a little bit, we say that master control can decide which way, in a way, which way it goes, which of the two parts is working when. And how would that, I guess that's more Valentina, perhaps. And then maybe a second follow-up, do we see this as a transitional technology, or before intermediate step before, for example, a full electric heat pump is installed, or is it more of a longer term solution? And I would say, if you consider, for example, the gas part being supplied by renewable gases, biomethane or others, and perhaps this also for Fabio a question. But Valentina, perhaps on the parameters, I don't know if you have an answer for us.
Well, I don't have a clear answer, because the logic is something which is a property of the manufacturer, so it depends on the manufacturer. Basically, to consider the optimization.
It is possible. It's something that it is possible, let's say, no?
It is possible because you set that on the CO2 savings, and how to ensure that this is put in practice. I don't know, because if the end user realize that by optimizing the CO2 he spends more, for maybe he can change the parameters, but I don't know if we can control directly the habits of the end user.
I guess the end user always, in the end, it does what it wants. And so also, you cannot control whether they open all the windows and keep the heating on the whole time. That you cannot control. But let's say from a technology point of view, it is of course possible to do it.
It's possible
to make sure that
course.
the criteria is CO2 emissions, and that's the winning criteria when switching on within one or the other. You
can do, but if you set that as a fixed parameter, you have no more this flexibility of the appliance, which is one of its pros. So I would not fix it on the CO2, but I would leave it flexible and adaptable to the grid and to all the needs we have. So it's possible, but not.
Can we go to maybe a bit the idea of the longer term, shorter term? I don't know, Fabio, how do you see it from the side of the grids?
Yeah,
operator?
first of all, let me just go back for a second to the last point that Walid made on the role that hybrid systems can play in allowing the grid to operate with more flexibility. This is crucial. This is really a key feature of hybrid systems that we should not be looking as a byproduct. Let's say this is a built-in feature that is going to be increasingly important. Another benefit, of course, that we should not forget is the potential risks that we may run into by relying on a single energy carrier in the future. We've seen what happened in 2021 and 22 with gas, but the same could happen in the future also with electricity. So there's always also this key topic of security of supply, let's say, and of having a resilient energy system that should be not disregarded. Then coming to the question of whether hybrid systems are a transitional or permanent solution, they may be transitional in some situations, but overall we see them as a technology that could be potentially used forever. There's no, we do not see why with a let's say a gas mix which features an increasingly high share of renewable and decarbonized gases, we should not still rely on the very good gas infrastructure that we have, and rely on the also very efficient solutions that we have for gas-based heating. So no, we see it as a potentially long-term solution to building to heating in the building stock.
Yeah. Well, I think it's the same approach probably in the Netherlands, no? Given also the policy support in this framework, or am I wrong?
Certainly, but on both questions, I would answer maybe as a bit technical answer in that regard is it depends. Because when you look at what achieves the most CO2 savings, it actually depends on the the energy mix of the country this question is being asked from. I'm not necessarily sure that the electricity production in that specific country is much greener than emissions of the gas usage. So that's very important to realize when we have CO2 savings. It does not mean that you have to use as much electricity as possible in all cases. So in that sense, we would advise as an industry, make sure it runs as efficient as possible and apply it in that manner. But also on the second part, the hybrid is definitely a transitional technology, but can also be an end technology, because that also depends on what happens in the coming years on the energy supply side of it. Because in the Netherlands, from 2030 onward, we have the obligation to mix in 10 billion cubic meters of renewable gas into our national energy grid. So when you have that supply of renewable gases, then you can also use that renewable gas. So for some people, it might be an end solution. For some people, it might be a transitional solution. And that is also the flexibility that the hybrid provides.
Yeah, no, that makes sense. That's correct. I have a comment from Valeria, colleague from Solar Heat Europe, who rightly mentions, how do we include solar thermal in the picture of hybrids and and hybridization. How, if you can comment on that. Obviously, solar thermal is a key component in the market in many markets actually of our of industry proposition in terms of heating. But on the hybrid specifically, Valentina, can you mention something? Maybe Valentina, coming from a sunny country.
Yeah, thank you. Yes, I fully agree. Also, the draft regulation eco design has introduced this solar hybrid, so they're welcome, and we believe in this kind of hybridization, of course. They are not in this paper because our paper is focused on hybrid heat pumps, but in the future we can also have something else, some other discussion on these points, of course.
Can I ask maybe a question, sort of unscripted question, which I think is, however, always an interesting point. What about costs? Yeah, what is this interesting from a cost perspective towards the consumers, or the energy system in general? I'm mentioning this for the consumers, of course, interesting because the transition costs money for all of us. So that's an important decision criteria, and we've seen with Valentina that incentives are driving this technology and heat pumps technologies as well in broad terms. But is there a specific good proposition on the cost side that hybrids can offer? Yeah,
currently, an hybrid has a price which is between a gas boiler and heat pump, because you have to compare the corresponding heat pump with the higher power than output respect to the hybrid, in which you have a smaller heat pump. So the price is average lower than standalone heat pump, and additionally you don't need any other works on the heating system, while sometimes when moving directly to a heat pump from a gas boiler, huge refurbishment is needed, both on the heating system and hopefully also on the insulation. So it is useful to have what we call a staged renovation, because you can have an immediate advantage by replacing with small cost the old appliance, and then when it's possible also to go further with other works on the building. So this is very interesting because the price is of course lower, and there are important savings at the end in the running cost.
Yeah. But if you wanted to add there something?
Yes, the interesting thing is that we look at costs and also returns on investment, which is how most consumers are driven. When we look at the last 2-3 years, it's been crazy how during the energy crisis, what the prices of the energy did for the return on investments of certain technologies that maybe prior to that, and maybe even now, would be deemed infeasible economically. So we have to also look at the policy around from a Dutch point of view, at least, maybe preferably also from European point of view, how do we price the CO2 intensity of the energy carrier properly? Because if you, for example, at the hybrid, we can use natural gas, but also renewable gases and also electricity. If, for example, and that's maybe for a future discussion, if a hybrid can manage to reduce the natural gas consumption, but the CO2 intensity of that natural gas consumption is significant in CO2 savings, but the energy prices for gases are lower, then the returns on investment are going to be longer. However, you're saving more CO2. So that kind of thinking, I think, from a policy point of view, is something we also have to realize: is what is the CO2 intensity of our energy carriers, and what are we actually saving?
Can I jump in on this maybe? Let us not forget that in a few years' time we will be starting emission trading for fuels used in the building sector. So here we will have carbon pricing for fossil fuels used in heating for our buildings, and this will provide on the one hand, a very important price signal for decarbonization. But on the other hand, it will be probably a policy that will be disproportionately affecting those segments of our population that maybe lack the financial means to carry out the renovation of their house or energy efficiency interventions. So here we will need to be very, very careful to ensure that we do not create social and economic disparities, and we do not drive a wedge between those who can afford the clean transition and those who cannot. This will be also a risk for let's say, the political legitimacy and the political buy-in of the green transition itself. So it is certainly important to provide the right price signals, but we will also need a huge investment and a huge commitment from the whole of our societies to make sure that no one is left behind in this transition. We now have a significant amount of resources, for example, through the Next Generation EU available for the green transition and also for the building sector, but these funds will run out now in 2 years' time. And the question is what happens after 2026. This will require, of course, a much higher level of debate than the one we are having today, but it is certainly a discussion that we need to have now, because it is indeed just behind the corner.
Yeah. And I mean, we are getting near the next European elections, and I already hear the words, we have done the green, we need to do the deal. I think this, what you mentioned, Fabio, is part of that. You know, how do we make sure that everybody's behind it and everybody's now implementing it, and that it doesn't really leave anyone behind. This is a challenge that I think it's on the agenda of the next European Commission, the next European Parliament. So I think we will see more of this discussion and hopefully concrete actions, because that's really what is needed. I think more pragmatism now. How do we actually make those targets come true? And what are the technologies that bring them there? And what are the ways that we can convince people and bring them along with us on this journey? I'm looking at the time. That's all the time that we actually had. So there's a couple of questions, but I always like to, end these events with, maybe we would like to talk a little bit more, but we don't have the time. So maybe we will do this again later on, rather than, oh my God, this was really, really too long. So I'd like to end the discussion here for today. Thank you very much, Fabio, Valentina, and Walid. For everybody else that has been following this and wants to know more about this paper, you can find it on our website, www.ehi.org. And otherwise, thanks for participating, and a good weekend to all of you. Thank you.
Thank you very much.
Thank you.
Thank you very much.